Hi, my name is Ali Amr. My ID is 34-458. The code of the CNC machine works by taking in a binary image, analyzing it, and printing it out on a piece of paper.
Hello, my name is Mohammed Khalid Al-Gubali, ID 34-2519, and this is a video demonstration for our GCN Digital System Design project. Our project is actually a CNC machine programmed on Verilog, embedded on an Altera board. Now, for those of you who don't know what a CNC machine is, it is a machine that acts like a printer. And now for the demonstration.
My ID is 34-5460, and now I'm going to demonstrate how this thing works. There are two L293D drives. Each drive controls the steppers, the bipolar steppers, and it takes the input from the batteries, and the sequence needs to go from the Altera board and sends it into these steppers to move this one in the Z-axis, and this one in the Y-axis, or X-axis, and this is the Y-axis. It moves the pen up and down using this servo. And yeah, that's pretty much it.
Okay, hi, let's start. So the servo moved the pen down. This moved into the Z-axis. This is stuck. It's supposed to move in this direction. Okay. So,
8 different outputs here, 4 each. 4 for the motor here, which controls the Z-axis, and 4 for the motor up here, which controls the X-axis. And the output through the IC chips controls the stepper.
So yeah, the servo is supposed to move the pen up and down, and this is supposed to move it in the Z-axis, and this is the X-axis. And there are two L2 drives that take the output from the Altera board and transfer it to these steppers. And yeah, that's it.
okay, so the original concept was that it would take a 2D array of bits and go through these 2D array to these bits, for example, like a for loop, but we could not implement that. So this is pretty much what we came up with.
Hi, my name is Ahmed Tariq, 34-4129. Let's show you some of the code. Basically, our model takes in the clock, which is 50 megahertz. It's converted into a 2-second clock, which runs the mainframe, and connected to a nanosecond clock, which is used to run the motors. It outputs a certain sequence to the servo, and it outputs 4 sequences to the X-axis stepper motor and 4 sequences to the Z-axis stepper motor. Here, the picture is initialized. It's a binary image. We go into the 2-second clock. It checks if this pixel in the image is a 1. If that is, it orders the servo to move down and stops the sequence given in for going up. Else, it moves it up and stops the sequence going down. Now, if the count x equals 124, means it is at the end of the X-axis. It starts the sequence to move left, moves the X-axis all the way to the left, and checks if count y is at the end. If so, it terminates. Else, it increments the count y and moves the y-axis. The z-axis moves the z-axis 1 position up. This is pretty much what happens. It repeats this sequence 40 times, which makes the stepper move 2 steps. which are 2 steps per dot. So it's the DPI of the motor is 125 times 63, and each dot is 2 steps from the stepper. Here it moves the x-axis. Next we have the nanosecond clock, which controls the servo. It has the if function. If down is true, it gives it the sequence, it moves it down every 2000 nanoseconds, which is 2 milliseconds. It's given 150 of high here, 150 nanoseconds of high, and 1850 of low. And this is the opposite direction, which is given 54 nanoseconds of high, and the rest of the 2000 nanoseconds are low. And that's how the servo works. The stepper, on the other hand, takes a sequence which changes every 5 nanoseconds. This is pretty much the sequence that it has to take to move clockwise. AX, BX, CX, DX. These are 4 different magnets in the stepper, and with this sequence it makes it move clockwise.